morning students. In this video we are going to learn continuation of unit number 9 electrochemistry. Today we are going to learn the subtopic electrochemical cell. Okay. In title itself is having a clear information what we are going to learn today. Okay. That you know that one chemical cell, then electro you know, the chemical meaning you know, the cell meaning you know. So electron is produced in presence of chemical reaction. That is the main concept we are going to learn step by step as a sequential manner in this video. So I give a small recapitulation about my previous classes. First we are learn in Diepy-Onsager equation, you know that one. Then Kohl's law, the infinite dilution. Then the instead of Kohl's law with applicable to only a strong or weak electrolyte, only for the strong electrolyte as well as a weak electrolyte. So we can use a strong weak electrolytes mainly using for the calculation in Kohl's law, but we can use the strong weak electrolyte equation for the strong electrolyte also. That also given a same information for we are getting the experimental value. Then the sparingly soluble salt. Then it's a minimum soluble salt or weak electrolyte. How they are going to dissolve, what is the constituent ion we can get. Okay, these are the things we have learned from the previous classes. Now we are going to see our main topic, electrochemical cell. Okay, first you can understand what is meant by electrochemical cell. In name itself, the electrochemical cell. So while we are doing a chemical reaction, the electrons are interchanged. With the helpful of interchanging the electron, the electricity was produced. That is instead of happening the some of the electrolyte solution. So we are simply say the electrochemical cell which generate an electricity current are called your voltaic cells or galvanic cells, and those that generate a chemical reaction via electrolysis, for example, are called as the electrolytic cell. Because why we are saying the electrolytic cell, the electrolyte is acting as a medium to producing electron. So only we say that is called a electrolytic cell. A common example, a galvanic cell is stand for 1.5 volt cell meant by consumer use. While we are buying the one everready battery, the everready battery is mentioning the 1.5 volt. What is meant by 1.5 volt? Why they are mentioning? Instead of the electrochemical cell will be producing only the 1.5 volt. Afterwards, the electrolyte get degraded or loses the tendency. So only we say the battery get lower. Otherwise, we said the battery was exhausted. We can throw it. We can insert another battery. So you can understand this. The electrochemical cells is generating a electric current. So the electrochemical cell is a device. Device means it's a battery. It's converted into chemical energy. It consists of two separate electrode. What are the electrode? First one is anode, another one is cathode, which are connected within the electrolytic solution. The electrochemical cells are mainly classified into two major types. What are the types? First one is galvanic cell or voltaic cell. Okay, it is a device. Its spontaneous chemical reaction generate an electric current. It converts a chemical energy into the electrical energy. This commonly known as batteries. What we can using in a home things is one of the above. Where the battery is a best example for galvanic or voltaic cell. You can don't confuse, both galvanic or voltaic cell is a same type of working progress is happening. Sometimes they're asking explain the galvanic cell. Sometimes they're asking explain the voltaic cell. Don't get confused. You can go through a galvanic cell also equal same, voltaic cell also same meaning. Okay, it is a chemical device. Spontaneous, I said already, is spontaneous. Once is getting going through that end, the end will be is there. Afterwards is can't able to generate revert it back. So it only we said the spontaneous chemical reaction generating. Then Electrolytic cell. It is a device which an electric current from a external source devices non-spontaneous reaction. It is converts electrical energy into a chemical energy. It is the best example for our electronic batteries. What we can using in our mobile batteries, what we can using our laptop batteries, all the rechargeable batteries are coming under electrolytic cell. Okay, once the battery get drained, what we can do, we are going to insert a external electrical source. What we can having that our plug point, the plug point is containing external electrical source via the charger. The external electric source is going to inside the battery. It is converted again the electrical energy into the chemical energy. After that battery get filled, what happening, the electrical energy get started to converting as a electrical energy. Like this rotation is called a electrolytic cell reaction. This is coming under the non-spontaneous reaction. Okay, so you never don't confuse. Galvanic cell is a spontaneous reaction, then electrolytic cell is a non-spontaneous reaction. The non-spontaneous reaction means once get drained, after we can supplying any external source, we can regenerating a chemical energy at 100%. Then we can remove our external source. The chemical energy start to drain, converted as a electrical energy. So this vice versa process is called a non-spontaneous reaction. Okay, for galvanic cell is best example for our laboratory battery. The electrolytic cell is the best example for our everyday mobile battery. Then now we are going to see that galvanic cell or voltaic cell. So when a zinc metal strip is placed in the copper sulfate solution, okay, the blue color of solution is faded. So we are taking only a chamber. The chamber is containing a copper sulfate solution. The copper sulfate solution is colored as blue. When we are inserting a copper sulfate solution to a zinc metal strip like a paper strip, the red to brown crust due to the following spontaneous chemical reactions occur. See, zinc sulfate, copper sulfate as a solution is aqueous medium, zinc as a raw strip medium. So what happening? This sulfate going to attack with that zinc solid state. We get a copper as a solid form. What happening? The zinc metal strip will be changed red color to brown color. Red color to brown color. Okay. Finally, the copper 2 plus ion. What happening the inside? This 2 plus will be in aqueous medium. It loses a 2 electron and get a copper solid. Is containing a reduction. You know that one. Whether the electron is removed from the substances is called reduction. Whether the substances is accepting electron is called a oxidation. See, zinc is getting an electron from sulfate. The copper is losing electron from the sulfate. Okay. So reduction, oxidation will be occurring in the same place. Okay. Now one side is the oxidation of cell, another side is a reduction of cell. The joining of cell. What is meant by joining of cell means the intermediate one bridge will be acting. One bridge will be acting. That is called a salt bridge. The salt bridge will be helpful to neutralizing the chamber without any affected by the solution. The galvanic cells and the batteries are typically used as a source of electric power. They energy devices for high cohesive energy, metal dissolving. See, understand the metal dissolving. Why the lower energy metal is deposited and or forming a high energy metal ions plating out while the energy ions of the solution. Okay, what happening the inside? The oxidation, while the electron will be accepting from the sulfate solution, the oxidation is happening the metal strip, the reduction is happening the aqueous medium. So this metal strip aqueous medium joining one medium is there, the joining of cell. See, now I am going to show that one. The electrolytic solution. See, electrolytic cell, this is a galvanic cell. So this, now I am explaining this one, the copper sulfate solution strip is dipped in a zinc metal. This is a zinc sulfate solution I insert in a copper metal. What happening? This zinc copper sulfate solution, the sulfate ion going to attack with this metal. We get a pure copper. This happening copper zinc sulfate solution. All the sulfate ion going to attack here. Only we getting a pure metal ions. This types of electrolytic galvanic cells is getting a finally pure pure metal ions. Once all the sulfate solution is converted as a metal ions, only the remaining portion is there only for a metal ion in the solution. The salt bridge is neutralizing the medium. This exchanging the sulfate ions to here. This is over to mean this exchange the sulfate ions to here. So the salt bridge is acting as a neutralizer part. Okay. See, this is a clear construction diagram about our Daniel cell. Daniel cell is Daniel cell is improvement of voltaic cells. What are the voltaic cells? Another version of galvanic or voltaic cell. That is invented the British John Daniel as at 1836. Okay. So is explaining extrapolate the two electrodes made up of zinc and copper order to producing a difference in potential. While we are using these types of electrochemical cells, we are getting a more efficient current. We are getting a more efficient current. See the principle. What is the principle in behind it? The redox reaction principle in behind is happening. Okay. In this process of the reaction can be transferred from the corroding. Corroding means the electron get degraded from the zinc rod. What happening? The electron get degraded from the zinc rod. The zinc pure metal will be converted as a losing a electron and converted as a zinc 2 plus ions. Instead of we are having a zinc sulfate solution, the sulfate is going to attack with the metal of zinc strip. So in this in the process of reaction, the electron can be transferred from the corroding zinc to a copper through an electricity conducting path. Electricity conducting path is our medium. Electricity conducting path is our medium. Okay, this is our medium. The zinc zone contains more electrons. So zinc dissolved more rapidly than water. Okay, so zinc dissolved more rapidly than water. What happening? All the zinc ions will be converted as a zinc 2 plus ion. So here the zinc sulfate deficient will be occur. What happening? This salt bridge is containing a sodium sulfate or agar with the help of agar-agar gel. Okay, this is helpful to donating a electron. Is helpful to donating a sulfate ions to the chamber. This is helpful to donating a sulfur ions to the chamber. This chamber is absorbing or taking a sulfate ions from the salt bridge. So the salt bridge is acting as a medium of neutralization. Medium of neutralization. With the cell reaction of galvanic cell is represented as a voltaic cell or Daniel cell. The common household batteries is a best example of galvanic cell. I already said. The flow of electron from one chemical reaction to another chemical reaction through a outside circuit. So this is called a outside circuit. This is a outside circuit. This is only happening for the Daniel cell, but this is not happening for the voltaic cell. So what is the unique characters is there? The unique characters is nothing but which prevent the polarization and interrupting the flow of electricity. The beautiful character of Daniel cell is not interpreting the flow of current because the salt bridge is helpful to maintaining electrical neutrality to the chamber to chamber. The salt bridge is helpful to maintaining electrical neutrality to the chamber to chamber. So what is the final EMF we get for this battery? Finally provided by the cell or battery per coulomb, charge passing through the current measured by volt. You know that one. So only we are purchasing any mobile batteries are mentioning a 240 volts like that. So depends upon the electromotive force and then electrolytics electrolytes, the volt will be differ. Okay. So the electrochemical cells, you know that one, the non-rechargeable batteries is the best example for galvanic cells, but Daniel cells is the best example for rechargeable batteries. Okay. So what is happening inside? What is the anodic reaction is happening? So zinc solid will be losing an electron in the aqueous medium. We get a electron. We get a electron. So electron loss is happening. We say it as a oxidation. Finally, what is the cathodic reaction? The copper 2 plus, the copper sulfate solution is accepting an electron from the zinc. We get a copper solid. This is gain of electron. Is called a reduction. Is called a reduction. So the salt bridge will be maintaining electrical neutrality. The electrolysis present the two cells are connected using a salt bridge. Okay. So the salt bridge is maintaining electrical neutrality. Okay. So completion of circuit. The electron flow from the negative charged zinc anode into positively charged copper cathode through a external wire. At the same time, the anions move towards anode and cation moves towards cathode compartment. This is a complete circuit. Okay. So this while we are movement is happening, we get a electricity. So combustion of electrodes. As a Daniell cell operates, the mass of zinc electrode gradually decreases while the masses. Okay, finally what happening? All the zinc metal is converted and said zinc 2 plus ions. So the converting as a zinc metal to zinc 2 plus ion, the mass, the weight of the zinc strip will be degraded or low. So of the copper electrode increases. Okay, so all the copper 2 plus ion in presence of zinc copper sulfate solution getting electron from the zinc sulfate. What happening? The density of the weight of the copper electrode will be increasing. The weight of the zinc electrode get decreasing. The copper electrode increasing, hence the cell will be function until the entire metallic wire. Electrodes is converted into a zinc 2 plus or the entire Cu 2 plus ion or converted into a metallic copper. With the zinc 2 plus ions is helpful to converting as a copper 2 plus into a metallic copper. Metallic copper is nothing but copper, solid copper. So how we are going to represent a cell notation? What we are using taken as a right hand side zinc solution. This is a chamber. What happening? Zinc solid finally loses the electron in the aqueous medium. Okay. This two lines are representing a salt bridge is there in between the medium. What happening that another half hand cell, the reduction cell, the copper 2 plus is accepting electron from in this end. We get a metallic copper. Okay. This is a common galvanic cell rotation. Don't ever forget. This is double line will be said that the two chambers connected via the salt bridge. Okay. So the galvanic cell is represented by cell diagram. Okay. The Daniell cell represented as, see the Daniell cell also represented a same type of galvanic cell, but instead of in above notation, the single vertical bar represents the phase boundary and a double vertical bar represented as a salt bridge. Now we can understand. The anode of cell is written as a left hand side of the salt bridge and the cathode of side is a right hand side of the salt bridge. Okay. The anode and cathode are written as a entire left and extreme right respectively. See, this is extreme right and extreme left. We are writing as a anode and cathode. So what happening inside? This is called a inside chambers containing solution. So the total EMF of the cell can be written the right side after the cell diagram. Right side after the cell diagram. See. So now you can understand, you can imagine this is inside that one, this is outside that one. This is left hand side, this is a left hand side and this is a right hand side. So the extreme, the standard EMF of cell 1.1 volt. Okay. So we can write here the extreme left, extreme right of the cell notation. So the net redox reaction of the galvanic cell is given below. See, we are taken as one example, chromium metal in presence of copper sulfate solution. The equation will be mentioned here. So we write the off cell and describe the using the cell notation. How we are going to write that off cell? We can take a anodic oxidation part. The sulfur, the what happening? This is here extreme left is called a anodic part. We take this one. CRS will be converted as here losing an electron. We getting a 6 electron while the CR is dissolved because 3 electron get dissolved. 3 electron we are getting from the only 1 mole of chromium, but we have here 2 chromium atoms, so we get a 6 electrons. So cathodic reduction, what happening? Copper 2 plus will be converted as a pure copper metal. So this 6 electron is accepted by a copper 2 plus. We getting a 3 copper metals, 3 copper metal. That overall cell notation CRS, CR3 plus. In between the salt breathe, Cr2 plus in aqueous medium, we getting a pure metallic copper. See, these types of questions are they are asking sometimes in 1 mark also. They are given the cell notations, an option they are given the n number of cell notation for variations. You can find out the cell notation of your reaction. So what is the EMF of the cell? The force that pushes the electron away from the anode and pull them the cathode is called a electromotive force or the cell potential. While the anode is reduced, electron get liberated from the anode, so that also is having a potential. While the electron is flowing through the anode to cathode, that is having to that also have some of the potential. So that is called the electromotive force. The electromotive force is produced by the electrons. So the SI unit of electromotive force is volt. Here we are using as a volt. When there is a no volt difference in the electrical potential between the anode and cathode. So while we are movement of electron from one cell to another cell, no potential differences are happening. Where there is 1 volt moving from here to there means that is also 1 volt is happening. So 1J is equal to 1C and 1V. This is a very important equation. No difference between the electromotive force for anode and cathode. So simply represented as like this. Sometimes they are not mentioning the one. They are simply mentioning J is equal to C into P. So here for your better understanding, for no same electromotive force means I am applying here 1J is equal to 1C into 1V. So the cell voltage depends upon the nature of the electrode, concentration of the electrolytes and the temperature on which the cell operator. For example, at 25 degrees what happening inside the Daniel cell. So Daniel cell is 1.107 volt they are producing. So this is our cell notation. So E0 is equal to, we know that one, they are already given. The volt is E0 electro. Finally, we getting energy is a E0. So this is a one schematic diagram for a zinc sulfate anodic cathodic example. You can go through it, see that what is that anode and zinc sulfate, zinc metal. So beautiful salt bridge. Instead of this is having the KCl. The voltmeter is helpful to observing the how many electron transfer to here to there. So this is helpful to identify your better understanding. So standard hydrogen potential. This is a very important one. Sometimes they're asking what is meant by She. Don't give the answer for any other. She in chemistry means standard hydrogen potential. See what is a beautiful character is having for She. The She is having a power inside the both anode and cathode are only one chamber. It's the best example for the schematic diagram will be explaining. See, the platinum electrode is in bottom. The electrolytic solution is happening filled with the inside. We are supplying any other gas. The gas is helpful to donating an electron to the electrolytic solution while the bubbling. Then the platinum electrode get degraded and degenerated. See, H 2H plus in aqueous medium liberating a 2 electron, we can get a H2 gas. We can get a H2 gas. See, measurement of electrolytic potential. Standard hydrogen electrode, she is used as a reference electrode. Okay, this is one of the important one mark question. What is the important character for she? What is the important character for standard and hydrogen electrode? That is a reference electrode. It has been assigned an arbitrary EMF of exactly 0 volt. So this electrode is having a perfect EMF value. Perfect EMF value. So the Daniel cell and voltaic cells don't have the perfect EMF, but here we are having a perfect EMF. Okay, the she can be act as a both cathode as well as anode. This is a very important point. Then the IUPAC definition about the standard electrode potential. The value of standard EMF of a cell which a molecular hydrogen under standard pressure is oxidized to a solvent proton at a left hand electrode. So this is a gas-based reaction. We are passing a hydrogen gas at a standard temperature and pressure. We can get a perfect electroconductivity. So I said already is acting as a cathode and anode. This is an example. This is a clear explanation for that one. See, H plus is gas inserted in 1 molar solution is electrolytic solution. It's liberating electron. We get a H2 gas at a 1 atomic pressure. Though if the she is used as a anode, what happening? H2 gas 1 ATM inserted, we can get H2 2H plus ion in aqueous medium. We get a 2 electrons. See the value 0 volt, the 0 volt. So we can easily find out the another chemical reactions, chemical potential with the help of reference electrode, because we know that when she is not producing any electricity voltage difference. So finally we get here another electrode value. See the following steps. It is the cell representation of standard hydrogen potential. Steps 2. The EMF above galvanic cell is measured using a voltmeter. In this case, the measured EMF above galvanic cell is 0.76 volt. How we are going to identify this one? Because this medium is inert medium with the helpful of transfer only happening here. So only we are taking as a finally easily calculated this value from this end. See that one. We know that one E cell is equal to oxidation and reduction. So we are using here the reduction area we are using as a standard electrode. We know that one 0 volt. So E cell is equal to 0.76 and reduction 0 volt. Substituting this value into above equation, we can take this here, we can get this answer 0 volt get vandalized. These types of easily understanding only we can getting a using as a she as a reference electrode. Don't forget ever she is acting as a reference electrode. So here one video. I'll give you a small recap about our section. What we have learned here, electrochemical cells and galvanic cell and cell notations and EM of the cell and standard hydrogen potential. So you know that one electrochemical cells is very useful for our olden days. The galvanic cell and cell notation, you know that one, salt bridge representation one. The vertical two lines are represented as a salt bridge and one single vertical line is represented as a boundary. Okay, EMF is a minimum energy and then electromotive force or potential. So one end to another end, the electron while moving, the volt difference will be 0. 1 V into CV. Like that the formula is coming. Okay, thank